So the first thing to do is to draw. So whenever you're given a polar stereographic chart, and this is so important so that you know the circle that you'll be drawing will be that meridian that you give, that latitude that you have, which in this case it's 75. So you just draw a circle going all the way around. Mine is not that perfect. So once you have a circle, you depict where north is. So for me, north is in the middle. So once you have north in the middle, then the next thing to do is to give your direction of where the Greenwich meridian is. So the Greenwich meridian is from north going all the way to this is a latitude. The circle that we've drawn is a latitude of, let me just write here, is 75 degrees north. So this is that latitude. So we are viewing it from the north, on top of the northern hemisphere. Yeah, on top of the northern pole. That's why we are viewing the north. So if this is 0 degrees meridian, so if you go this way, this is 90 degrees meridian, which is towards the west. This is 90 west. This is west, sorry. And then this is east, which is 90 towards the east, 90 east, which is east. And then this is 180, the anti-meridian of 0. So this is 180. I hope everything is clear. Okay, so having drawn that, you locate points A, B. So first of all, point A is on a latitude of 75, which is this circle, but now on 120 east. East is towards this side. Yeah, going this way is east. So from 0, you go up to 90. 90, if you move up a bit, you get to 120, 30 degrees from 90. So you just draw a line straight. Mine doesn't have to be perfect. Yours has to. So you draw a line. So this is point A, point E. And then A is at, this is 120. All this angle is 120. So here is 30. And then point B is at 160. So from 120 east to 160 east, that's 40 degrees different. So it's somewhere slightly there. Okay. So 160, you draw another line. So this is your point. Bravo. So the question is asking if a straight line is drawn from A to B, that is, you've drawn a straight line like that. So note that the straight line at A touches the circle, and the straight line at B touches the circle. So we'll see why that's important, okay? So what they are asking is that at a certain point, which is 155, this meridian now, these are meridians. These straight lines to the circle are meridians. So at this meridian, 155 degrees east, what is the track of this line? Because this track keeps on changing from here all the way to here. So another thing I need to point out is that when you're looking at the angles and you want to measure the true track of this, I know you're used to doing this. You draw a straight line and then you say north is here, then you measure your angle going all this way up to here or up to there. It doesn't work that way because where is our north? Our north is here. So this is a polar stereographic chart. So north is in the middle. So what you do if you want where north is, this is, you start to measure. If you want to measure the true track of this, true track is measured in relative to true north. So north is here. So your angle, initial angle from A to B is from here measured all the way to the track. As simple as that, because we measure our track, measure our track always from north going clockwise. So this is our track. Okay, so back to some uh, uh, triangle mathematics. Yeah? So just simple triangle logic. Let's draw this triangle that has emanated from that. So it looks sort of like this. So you'll see that this from north to B and from north to A, both of them are radius of the same circle. So this and this are the same. And you know that A was, this was your north, and then you remember there was that 90, and then 0 was here. Those are meridians here. So this was 0, this was 90, and then this was 120, this was 160. So from here to here, between 120 and 160, that is 40. Yeah? So this is 40. And then from, obviously, if these two are equal, so you just do 180 minus 40, you get 140. And then you divide it by 2. You get 70 on each of these angles. So here is 70, and here you also have 70. And then for this question, you don't need much because you just need that. So if they're asking you the true track, if they were asking you what is the true track at A, so we'll calculate first, get a true track of a straight line A, AB. So at, the first one is at A, give it, at B, give it, and then at 155 degrees meridian. Yeah. So if they were asking us at A, you just look at this. This is your north. So from north, you go clockwise all the way up to this, up to where the track is. And that angle from our calculation here we have seen is 70 degrees. So at A is 70 degrees true. At B, so you can look at B, the track goes this way, yeah? Goes all the way straight, yeah? So it's track going A to B. So remember, north is still here. North is not up. North is not anywhere else. North is here. This is your north. So you measure from north going clockwise to the track like that. Okay. That is on a track that is AB. If it was BA, you would have measured from north going all the way and then to the track on this side, going this side. But now we're going that way, going this way. AB, not BA. AB. So it's this angle from here to here. And we know that this is 70 from our calculation here. This is 70. So obviously this is a straight line. So 70 minus from 180, you get 110. So B is 110 degrees true. And then at 155, basically what I do is I just use ratios, yeah? Because at A, it was 120 degrees. The meridian was 120 degrees east. And then B was 140 degrees east. So the difference between these extremes, between A and B, if you get the difference between A and B, is the difference is 40, yeah? And the difference between A and this meridian is 155 minus 120, you get 35, yeah? And it increases, you can see it increases from 70 all the way to 120, 110 at the end. So the difference between A and B, the extremes, the difference between, this is A, this is B, yeah? The difference between A and B is 40. And then the difference between A and that place where we have 155 here is 35. So you just use ratios, because at 155 you can notice that that track is not touching the 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 circumference, the whatever, the circle. So you can't use the same principle that we have used to get a true track at any. So the only way that I would recommend you to use is by using ratios. Yeah. So you just do 35, which is from A to 155, of the whole now from A to B, which is 40, times this one, A to B, the track has changed by how much? It has changed by 70 to 110. So you do 110 minus 70. You get 40. 40, yeah? 40. So this is a change that you want to implement the ratio. So we know from A to 155 is 35. And then from A to B, that is, so that you don't confuse, that is in degrees of the meridian. So 35 degrees, and then all the way is 40 degrees of the 110 minus 70, which is the true track. The true track changes all the way from A to B by 40 degrees. So by 40. So you do that. For our case, it's simple, 35 degrees. So the 35 degrees will be the change from A to 155. Yeah. The track will have changed by 35 degrees from A to 155. So what you do is just you add from what the track was initially, which was 70 at A, plus 35. You get your answer as 105 degrees. True. As simple as that. Thank you.